You've clicked the link, right? I mean, of course you have. Probably a dozen times already today. But have you ever stopped to wonder what actually happens in that split second? Well, today we're going to pull back the curtain and trace the incredible, high-speed journey your click takes across the entire planet in the blink of an eye. It's a hidden world of rules, packages, and addresses, and we're about to map it all out. Let's dive in.
Seriously, it feels like straight-up magic. You click, and poof, the web page is just there. But it's not magic, not even close. It's actually this super-fast, perfectly coordinated dance of technology happening across thousands of miles. So what we're going to do is break down that dance, step by step.
And this right here, this is the fundamental problem the internet had to solve. You got to remember, in the early days, it was chaos. IBM made stuff that only talked to other IBM stuff. Apple only talked to Apple. It was like trying to build a global community where nobody spoke the same language. For the internet to even exist, everyone had to agree on one single, universal way to talk to each other.
And the solution? That's where something called a networking model comes in. It's the rulebook, the universal translator for the entire internet. The one we all use today is called TCP/IP, and it's the reason your Android phone, your friend's iPhone, and some massive server halfway around the world can all communicate perfectly. This house blueprint analogy is just perfect. But here's the truly brilliant part. Because it's a blueprint with different sections, the electrician can invent a whole new way to do wiring, like switching from copper to fiber optics, and it doesn't mess with the plumber's job at all. This layered approach is why the internet is so resilient and why we can keep inventing new tech without having to rebuild the whole thing from scratch.
All right, so let's start our journey. The very moment you click, the first thing that has to happen is we need to prepare the message. And this all starts inside the app you're using, like your web browser.
Okay, so let's set the scene. Your browser, we'll call him Bob, wants to get a web page from a server we'll call Larry. At the very top layer of our model, the application layer, Bob's browser creates a little message using HTTP. It basically just says, "Hey Larry, get me your main web page." That's it. That's our digital letter ready to be sent.
But here's the thing. The internet can be a messy place. Data gets dropped, it gets corrupted, sometimes it shows up in the wrong order. Imagine Larry sends that web page in 3 chunks, but Bob only gets chunk 1 and chunk 3. The page is totally broken. We need a system, right? A way to guarantee that every single piece arrives safely and gets put back together correctly. And that's the job of the very next layer.
So at this transport layer, we get a choice of how we want to send our message. If you're, say, streaming a video, you'd use something called UDP. It's all about speed. If a few pixels drop here and there, who cares? The video just keeps playing. But for our web page, no way. We need every last word, every image, so we use TCP. Think of TCP as certified mail. It checks for errors, it gets a signature for every piece it delivers, and it makes absolutely sure nothing gets lost.
Now, this is the first time we see a key concept in action: encapsulation. It's a fancy word, but all it means is we're putting our message inside something else. We take that HTTP request and put it in a digital envelope. And on that envelope, the TCP header, we write instructions like piece 1 of 3, piece 2 of 3, and so on. That way, Bob knows how to reassemble everything and can tell if a piece is missing.
And boom, we have our first official piece of jargon. Once our data is wrapped up in that TCP header, it's not just called data anymore. It's officially known as a TCP segment.
Okay, so our message is neatly packaged and its delivery is guaranteed. But where is it actually going? Now we move down to the layer that's responsible for addressing and routing everything across the entire internet.
And this quote from the source material just nails it. It really is the best way to think about it. The network layer's job is to be the internet's postal service. It doesn't care what's inside the package, just like the post office doesn't read your letters. Its one and only job is to look at the address and get it to the right destination.
So, how does the Postal Service know where to go? With an address, of course. And on the internet, that's the IP address. Every single device connected to the internet, Bob's computer, Larry's server, your phone, everything, has a unique IP address. It's the digital version of a home address, letting the network pinpoint exactly where our message needs to go. You guessed it, it's time for more encapsulation. We take that whole TCP segment, our first envelope, and we stick it inside a bigger box. Then, the network layer adds an IP header to the box, which is like slapping on the mailing label with the to and from addresses. It's got Bob's source IP address and Larry's destination IP address right on the front.
And with a new wrapper comes a new name. What started as data and became a segment is now officially called an IP packet. And you've probably heard that term before. This is the thing that actually travels, or it gets routed, across the internet.
Now this is super interesting. Your computer doesn't just shout the packet out into the void and hope it gets there. Instead, it sends it to its local router. That router is like a local post office. It looks at the destination IP address, checks its map of the internet, and says, okay, the next best step is to send it to that router over there. And that router does the same thing. It's this hop by hop by hop journey across the world until it finally reaches the router on the destination's local network.
We are so close. Our packet has zipped across the internet and it's arrived at the right local network. But we have one last tiny step, getting it from that local router to the specific physical computer.
So think about it this way. The IP address is like the street address that gets the mail truck to your apartment building. Awesome. But now, how does the mail carrier know to bring the package to apartment 4B specifically? That's the problem we have now. Our packet is at the right router, but it needs to make that final jump over the Wi-Fi or through an Ethernet cable to Bob's actual machine. This needs a different, more local kind of address.
So, one last time, let's wrap this thing up. The data link layer takes the entire IP packet and puts one final wrapper around it. It adds a little header and a trailer, basically to handle the addressing for this one specific local jump and to do a final error check. This is the final, complete package ready for broadcast.
And that brings us to our final form. This fully packaged, ready-to-go unit is called a frame. And this is the magic moment. The frame is what gets turned into the actual physical energy that travels through the network. The electrical pulses zipping down a copper cable, the flashes of light in a fiber optic line, or the radio waves of your Wi-Fi. This is where digital becomes physical.
Okay, so we've gone through this whole journey using the modern TCP IP model. But if you ever hang out with network engineers, you're going to hear some different terms being thrown around that come from an older model. It's really helpful to know what they're talking about so you're in on the lingo.
See, before TCP/IP won the internet wars, there was this other, more complex 7-layer model called OSI. And as you can see, the basic ideas are really similar, especially for the layers we've been talking about. And even though we all use TCP/IP today, for some reason, the numbering system from the old OSI model just stuck. It's a habit that network pros have never really kicked.
So here's your cheat sheet. If you ever hear someone talk about a layer 3 switch, they're just using jargon for the network layer where routers and IP addresses live. A layer 7 firewall, that's just the application layer. And you might hear the term PDU, which just means message. So a packet is a layer 3 PDU, a frame is a layer 2 PDU. It's just some useful industry slang to have in your back pocket.
And there you have it, the journey of a single click. A simple request gets wrapped and wrapped and wrapped, becoming a segment, then a packet, then a frame, before it's blasted as pure energy across the globe, only to be unwrapped layer by layer at the other end. All of that happens in less time than it takes to blink. It's this beautiful, layered system that is the invisible foundation of our entire connected world. It kind of makes you wonder, doesn't it? What other incredible, invisible systems are humming away right now, just to power our digital lives? Thanks for exploring that with me today.